So welcome to video 8, demonstration video 8 in our introduction to R course B05. So we're looking at for loops. And anyway, for loops are similar to if statements because we have a condition at the start. So we have a for and then a condition, and we're asking if this condition is true, then we do these things that are in curly brackets. Do these things. So for instance, the condition, instead of having, say, x greater than 2, it's a series of iterations. So there are ways of doing iterations before. For example, we might have 1 going from 1 to 10, and that might give us 10 iterations of something, or 10 going down to 1. Or we do things like where we repeat a certain number many times if we want to repeat an action. And so the for loops give us a way of doing that. So if we for a condition, and often you might use a variable like xx, and you might say if it's in the numbers 1 to 10. An easy way of looking at for loops is just to print out value of x as we go through this loop. So this is a simple for loop where we're asking xx to be printed each time it goes through the loop. And xx is an undeclared variable at this point where it takes on the values of 1 for the first loop, then 2 for the second loop, 3 for the third loop, and so on, all the way up to 10 inclusive, and then it stops. So if we print that out, what we see is that we get here is our numbers going from 1 to 10. If we change that around, so we go from 10 down to 5, again, that's what's printed out here. If we change the print statement, and maybe say loop running, it will print out exactly that repeatedly all the way through. We can so we can see how the basic ideas of for loops work here. It will just execute this for whenever these criteria are true. We can change that further. So let's say y is assigned the value of 2, 12, and 24. We can say for xx in y, print xx. Whereas before we saw that printing from 1 to 10 and so on, now it will take on the values of y for each element sequentially. So see that printed out as 2, 12, 24. If we change y to being something else, it will continue in the same way. So now y is 4 different elements, and it prints out each element as listed in order. So what we put in as the condition at the start depends, and it just loops through for each of the number of iterations of y all the way through. So what we can do is try the paste command as well. So we can say paste at the start. So paste, if you're new to paste just links different text and numbers together. So you could say my number is, and then have a space there, and then put in xx, and I'll say my number is minus 999 because that was that last value of xx. You can even put text afterwards and say test1 at the end. So you can see test1 is given at the end there. And then we can put that inside our loop if we want. So we can print out. So if you use print inside a loop to print out a number, if we don't put in print, then it won't work. Another option is show, which works just as well. So we're going to print out my number is. So you can see it says there, my number is 2 for my loop, and so on through each iteration of y. If we change that at the start to go from 1 to 3, it will take on those exact values, 1, 2, 3. If we change the criteria at the start further, just as if it was any vector, oh dear, using the C command, 266 minus 3, it will take on those exact values. So we put in at the start varies. We can also have more complex commands. So we can have two items that iterate within a loop, like k here, which is a constant. So we could define our kk down here as being 1, and then print that out as well. And let's just change the text here, and kk is, comma, kk. So you see kk does not change during the loop, whereas xx does. We can even access other elements within there. So we could change kk, and we had the values, the array y already. So y has 3 elements that we can access, because x has 3 values. We can add in a 4th if we want. We can access the elements in y by using y and by changing x. So let's just change x to a more sensible form than is given here. So let's change x to be 1, 2, 3, 4. My number is xx for my loop, so we're going to change that. And yy element xx is, and we're going to put in at the end here is a comma. We're going to say xx and, oh, sorry, we're going to say y with xx inside. So this is accessing element 1, 2, and 3, and 4 of y each time it goes through the loop. So if we visualize it, it might be more clear. We're looking at my number xx takes in the value 1 the first time and access yy element 1, which is 2. So let's see yy there. Oh, y, sorry. Y element 2 is 122, y element 3 is minus 24, y element 4 is minus 199. So the YY typo, it doesn't matter, because that's just text. So you can see it more clearly there. So we can simplify that and just say XX and element YY is this. If we changed X, it will no longer be able to access the correct elements of Y. And you see there for the 5th one, it tries to access the 5th element of Y, which is absent, and thus gives an error. So you can use these to practice your own loops, and there's other ones that do the same things as loops, like the function sum, which adds up a series of numbers, say like the numbers going from 1 to 10, or the elements in Y that act in the same way. So we can add iterations into a loop as well. So if we go back to our loop here before, we're going from 1 to 4, we can also have a counter. So what we could do is have a value s here. I'm going to count. S is assigned a value of s plus y xx. What we need here is a semicolon at the end. So s is some value, and I'm going to add all the elements of y into that. However, this gives an error because y is not present. So we need to define it first by just saying that y is equal to 0. Now the value s exists. So if we try this, it'll add all the values of y into there. Another variation on this is if statements inside a for loop. So an example of that is given in code. And if we change some of the code that we used before, going from 1 to 10, where we had this, we can say instead, we can have a criteria inside here. So we could say if this particular element of xx, this particular element of y, which is denoted by xx, if that is greater than 3, then we're going to print it out using the curly brackets. So print that value, which is y $xx. There we go. So it's going to loop through each of the items in y, and only one of them is greater than 3. So you can see that there. only 122 element 2 satisfies that condition. If we set is greater than minus 33, then we find that 3 elements are printed out. If we wanted to reverse it, we could as well. We can go backwards to y using the same item and change the order. And we can change the criteria as we had before. So you can say if it's greater than minus 33, and if y, the xx element of y mod 2 is equal to 0, we can check that if it's even. So now we get all 3 elements, and if we check that if it's odd, we get no items that fit that condition. And if we change it to if either condition is true, so that the single vertical line means that if either it's greater than minus 33 or it's odd printed out, we can see that all get printed out because minus 199 is odd. So we see that we can combine for loops and if statements together. And as above in this example, we can use counters within a loop as well, as we showed earlier. A final variation on this is nested for loops. So you can see an example of this here. So that's a bit more complicated. So let's go back. If we think of a simple loop, so we had an example there, var xx in 1 to 4. We could have, we just print out xx all the way through. We could have another for loop for zz in 5 to 7. And what we can say is that put a print statement for xx at the start. Each time that starts the loop, do that. And we use a semicolon to denote the different commands, and then print zz, and then the final curly bracket at the end to denote the finish of the first xx loop with the zz loop in between. So you can think to yourself, what is going to happen here along the way? So we're going to start with xx, taking in the value of 1. It's going to print that out. Then it's going to start in this loop. So it's going to print out zz is 5, zz is 6, and then 7, and then back. It'll end that because it's no longer true for higher values of zz. I'll go back to xx is 2, then zz is 5, 6, 7, xx is 3, 5, 6, 7, xx is 4, 5, 6, 7. So that's what we can see here. Xx takes the value of 1, then it prints 5, 6, 7, 2, and then 5, 6, 7, 3, and then 5, 6, 7, 4, and then 5, 6, 7. If we print it out more clearly, we can see that. Paste, nested loop. So we can see that nested loop. So each of the nested loops completes within each of the for loops. And it'll do it for whatever number of iterations that we want. So we could have a shorter nested loop if we wanted, and a longer for loop, and it'll keep iterating all the way through. Although nested for loops can be effective for dealing with certain data manipulations, or if you're comparing data, there are other alternatives that we'll look at next with when we're looking at tidy data or in video 9. And there's also other data structures known as hashes, which we'll learn in other courses, which are also very good at manipulating data as too. So that's the end of video 8.